I have here a pair of coffee filters. This is a single filter. You can't really see it, but there's a filter inside of the filter here, so this is two filters. And as you've seen, when I drop these, the single filter will tend to hit the floor a little later than the double filter if I drop them from the same height. Now the question is, from what height do I want to drop these filters in order that they hit at the same time? We've tried this, dropping one from twice the height of the other, and in class we actually observed that they tended to hit about the same time when we did that, but we just saw that the one that's dropped from half the height hits before the one that's dropped from the greater height. So let's try dropping them from a different set of heights. Let's try here. Now the doubled filter hit just a little bit before the single filter, so let's go down a little bit lower. Now the single filter hit a little bit before the doubled filter, and maybe a little higher. Well, it's going to be kind of hard to make this happen. That's about right. Now I observed that the single filter was dropped from somewhere around 65 to 70 centimeters when they hit simultaneously, at the same time that the single filter, or the, let's see, I don't know if I said that right. Single filter was dropped between 65 and 70 centimeters when the doubled filter was dropped from 1 meter. Now this isn't consistent with what we just saw from the data in class, that when the single filter was dropped from 50 centimeters it hit the same time as a doubled filter. And remember that we concluded from the fact that the single filter drop from half the height takes the same time as the double filter drop from the full height, seemed to be an indication that the air resistance on the single filter, that the air resistance was proportional to the first power of the velocity. And that seems to no longer be the case here, and we want to talk about what the proportionality might be.